Thank you everyone for joining. Sorry for the late start. We
Hello.
have Jeffrey Wang presenting today on learning DAX. Since it's getting a little late, Jeffrey, I'm gonna make you the presenter.
Hello.
Yes.
Can anyone hear me?
Yep, we can hear you.
Hello.
Yes, I can hear you.
Uh, yeah, I'm trying. Let me. I can hear you. Yeah, for some reason I can't hear you. Okay, let me switch to. Uh, well, I'm getting a bad echo. Let me turn this one off. Is it better? Can anyone hear me?
Yep, I can hear you.
Okay, that's great. Sorry about that. For some reason, I can't hear anybody on the other machine. I have to switch to a machine. So sorry for the delay. And let me try to. So you can see my screen. Are you seeing my screen? Because
Yep,
I hear
we
it.
can see the GoTo webinar link.
Okay, so let me open PowerPoint, my PowerPoint slide. I'm opening my slide deck. Let me know if you can hear me, if you can see it.
Yep, we can hear you, and we're waiting for it to load.
And can you see my slide deck? My first.
Yep.
Okay, that's
Yep.
great.
The
So
learn DAX by studying.
okay, so sorry about the delay. Shall we get started?
Yep.
Okay. So learn DAX. So my name is Jeffrey Wang. I'm an engineering manager at the Microsoft Power BI team. I joined Microsoft. Actually, this month is my 15-year anniversary at Microsoft. I moved here from a suburb of Philadelphia 15 years ago to a suburb of Seattle. And I stayed with the Microsoft BI engine team ever since. So in the past few years, I led the development effort of the DAX programming language, query processor, the calculation engine, direct query, and the composite model, basically all programming language and modeling related features of Power BI. So today, I'm going to give you an overview of the DAX programming language. So for all the users of Power BI, they know that the product is very powerful out of the box by just doing point and click, drag and drop operations. But the product has a lot of depth. People learn that. One of the reasons why Power BI is gaining popularity in the marketplace is that many people found that the product has a lot of depth. And the DAX is the tool that will bring out all the power within the BI engine behind the Power BI. But for users of DAX, we have heard two extremes of feedbacks. Some people say DAX is very easy to learn. Some people say that DAX is hard. So which one is true? Is it because when you do the simple and easy things, the beginning things, DAX is actually pretty easy to learn. But once you move beyond the beginner's phase, trying to do some serious analytics and calculations, you will hit a wall. And some people have heard about the abstract concepts like row context and filter context. What are they? Why is it so hard for some people? And is it Microsoft doing another bait and switch trick on its users to make it something seemingly easy and just to trick you? Of course not. Right? So we're going to debunk some of the myths of DAX to help the people who, those students of DAX who like to answer some of the frequent questions they often encounter and puzzle them. So we'll start with a brief history of DAX, and of course, this most important so-called abstract concepts, the two evaluation contexts with row context, filter context, what are they, why they're there, and some of the special things in DAX that students often find puzzling, especially if you come from a background of other programming languages, like many people come from Excel background, they have learned Excel formulas. Many people come from like a SQL, some people come from Python. So every programming language have its quirks. DAX is no exception. But some of those things tend to throw people off because that's not what they're used to. So let's start with some basic information about the DAX. Right? And DAX was invented in 2009, so it has some history, but the real reason the Microsoft Power BI engine is powerful is that DAX is standing on the shoulders of a giant. Microsoft, before we invented Power BI, Microsoft was already very successful in the business analytics market. SQL Server analysis services started 20 years ago. So this is the 20-year anniversary of that product. So we started with a multi-dimensional model. The programming language used is MDX. So DAX actually is a natural evolution, or you can call it a revolution, from the multi-dimensional model and MDX programming language. So even though the DAX itself started in 2009, the history of Microsoft BI engine go all the way back to 20 years ago, which is why you see so much depth in a BI engine that is today. So where does DAX come from? So we already said that DAX is started in SQL Server analysis services, and then as a Power Pivot that is adding into Excel. That is Microsoft's the first effort to move from IT-sponsored BI, that is SQL Server analysis services, to a self-service BI. So the initial idea is since Excel is the most popular Microsoft BI tool, or the BI tool in the world, why don't we just add those advanced analytical capabilities directly into Excel? So that's where we started to create the tabular models and the DAX. So because of that, one of the design goals of DAX is that it will eventually be a part of Excel proper. So it conforms to all the Excel formula language design, like it's a functional syntax. We actually directly incorporated many Excel functions directly into DAX. Then you may ask why we need to have Excel formulas if it's already there, right? So why do we want to re-implement it in DAX? Well, the reason is analysis services is a part of the SQL Server team. Therefore, we are a part of the database team. As a database engine, we can handle large data volumes. Well, Excel, even after it started with every sheet has about a 64K limitation, and then it increased that to 1 million, but still Excel is not truly designed to handle large data volumes. On the other hand, the analysis services engine has always been designed to handle large data volumes. Millions of rows is no problem. Hundreds of millions of rows, even billions of rows can be handled by this engine. So we have to take the Excel formulas as they are and retrofit them into this powerful database engine so that they can work over billions of rows of data at lightning speed. So Excel formulas is definitely one of the main inspiration of the design of DAX. The second inspiration for DAX is the SQL, right? So again, we come from SQL Server, a database team. Therefore, we want to handle large data volumes. We want to handle many tables. Unlike Excel, is working cell by cell, right? You can see every sheet. You can refer to different cells within a sheet or across the sheet, but still it's based on individual values. All the calculation formulas are based on individual values, while the relational database, if you have any SQL background, you know that it's all operated on tables, columns. So we have to mix them together in order to have the versatility and the usefulness of Excel formulas, and also at the same time you can operate on structured data like tables and columns and the relationships between tables. The last but not the least main inspiration of DAX is dated back to our original background in the multidimensional model, where the MDX was the programming language. So what's so special about the MDX? Actually, let me explain what's so special about each of the three programming languages. Excel formula, as I said, are super powerful, but they work on individual values. They're like they're easy to understand because you understand they're just like mathematical functions. You have 3 inputs and you generate 1 output. And the SQL, I explained, it works on tables and columns. So it's on rows of data instead of individual values. While MDX is different from the previous two in that it has this has this very important concept called measures. Okay? Measures is one thing that does not exist in either of the previous two, and that's what make a BI. It's a very, very unique thing. This is also the key reason we need to invent yet a new programming language instead of just reusing or extending the existing ones, because this fundamental concept of measures. So what is a measure? Measure is an abstract formula that just simply work in all kinds of situations. And well, it's best to talk about. I believe most of you have already seen measures, but let me just show an actual demo to make it very clear that why measure is so unique and powerful in Power BI. I'm opening desktop. Let me know you can see it or not. Sorry, I opened it on my other machine, but I have some technical difficulties over there, so I have to switch to this machine, so it's not pre-opened. I have to open it again.
We can see it, Jeffrey.
Okay, that's great. Okay, so let me move this away. And so I have a model here. I can show you that this is based on the internet sales. It has many tables. You don't have to worry about the exact schema. The general idea is you have a fact table called the sales, and it has many dimension tables like a product, date, geography, customer, the typical demo database from Microsoft. So there are many measures defined in this model. I'll just show you one example. Okay. For example, there is a measure called new customers. So today, we're not trying to learn all the DAX functions. We obviously don't have time for that. Okay. So the idea is I'm going to show you that what can be done in Power BI and what are the general concepts and ideas. And this way, you don't have to. So when you get ever lost, you know like where you are and what kind of questions you can ask and how you find out those informations on the internet. Power BI has a very helpful and active community, and there are many MVPs out there writing blog posts explaining all the DAX patterns and how to solve concrete problems. So you can find out yourself afterwards. But today we're just showing the big picture, the mile-high overview, so that when you try to do something, when you think about something, you will be able to ask the right questions and move in the right directions, and also debugging your own formulas on your own. So, and you don't have to understand every single thing in this formula, but I will just go over it. It has several steps. So this measure is called new customers. What it does is it will count the number of new customers. But what do you mean count the number of new customers, right? So this question obviously only makes sense in a specific context. So, but if you look at the formula, what it does is it says the first step, I define a DAX variable called customers in this period. So it will just return a list of customer keys in the current period. And then the next step is I calculate another value saved in a variable called the first date in this period. So what it does is for the current period, whatever the period is, I will return the earliest date in this period, saving that variable. The third step is a more complex one. What it does is called it's a variable. It saves customers before. What does it mean is I'm calculating the list of customers that has made a transaction before the earliest date I just calculated. Remember, in the second step, I calculated the earliest date. So in the third step, I just calculate the list of customer keys for those customers who have made a purchase before the first date I calculated in the second step. And finally, I calculated the difference between the customers in the current period, which I got in step 1. It's a list of customer keys who has made transactions in the current period, and then the list of customer keys who has made transactions in the before the earliest date of the current period, which I got in the third step. And then I take the difference between these two sets of customers. And finally, I use the count rows DAX function to count the list. Okay, so even though you may not understand every single function, you understand the logic makes sense, right? But it's also magical because obviously this formula is written in abstract, right? It's not in any particular report because it doesn't have to be. It will always work in any particular report. So, for example, on this page, I have several visuals. Okay, and so on this visual, it's a line chart. If I click on it, you will see that it's over date, so over a time period, and then I have several measures on it, and one of the measure is new customers measure. So if I hover over any data point, you will see that the number of customers is, I have several measures here. The number of customers is 193. The number of new customers is 175. So now this measure, the new customers measure, has a specific context. And in this particular context, it is November 2013 from the axis. And you can see I have selected for the blue products. So we're talking about the new customers who have bought blue products. And I have another slicer on gender. So it's a male customers who has bought blue products on this particular date, or actually in this case, in this particular month. So you can, and so I can choose a different product colors. Let's say who bought a gray product. I know nobody bought a gray product. So how about silver? Yeah, so silver products. And I can switch to female product. So you can see we wrote an abstract formula called new customers. It's quite sophisticated, but it just magically works in any particular context. So this is the power of measures. So the fact that you can pre-craft a formula independent of specific queries and specific reports, and you can drag it onto a report, it just works. And for all the different kind of visuals, I can switch to a table visual or to a column chart. In this case, it's a line chart. I can slice and dice it using all kinds of filters, and this formula just works. So this is the power of Power BI, and this is why measure is such a fundamental and important concept. Let me put the focus on my slide deck. Okay, so let's go back to the slides. So measures, measures. We originally had measures in MDX, and now we inherited this important concept in Power BI. And another thing special about the MDX is all the joins are implicit. So in Power BI, one of the reasons Power BI is powerful is that you can have many tables. You can connect it. You can connect all those tables using all kinds of sophisticated relationships. You may have heard of like a one-directional cross-filtering, bi-directional cross-filtering, and you have a many-to-one relationship, one-to-one relationship, many-to-many relationships. So all those kind of things, and you only create it in the model, and then when you go to the report, you can just drag and drop. The reason you only drag and drop and it just magically works is because all the joins are implicit. Unlike in SQL, all the joins must be explicit. So SQL gives you maximum flexibility to join. You can say, I want to join product table with customer table where product key equals customer key. Even though it doesn't make any sense, but the SQL allows you to do that. But the Power BI is different. Power BI, you pre-join all the tables through the diagram view, and then afterwards, during the query phase, you no longer specify join. That's how the UI can generate the joins. The queries are so fast. All the query does is, I want this column, this column, this column, set this filter, that filter, this filter, and then measure 1, measure 2, measure 3. And then the report just works. You don't have to say how all those measures, columns, filters connect to each other because they are predefined in the model. This is another reason why for experienced users, they know that unlike many other products, Power BI is a model-based BI tool. Well, for example, Tableau is not. Tableau is a report-centric BI tool. Okay, so since we talk about the Power BI is inspired, the DAX programming language is inspired by 3 major languages before predecessors. So let's look at how how the individual DAX functions are come from where. Okay, so there is a big set of functions we directly got it from Excel. And by directly, it literally means because Excel and Power BI were the same within Microsoft, so we share source code. And so Power BI literally took the actual Excel source code that implemented many Excel functions and directly integrate that into our BI engine. All right, so that's why they have identical semantics and the syntax as Excel. So if we look at the different functions, you can say, first of all, it's many operators. They behave the same as Excel. And then we have many date time functions. We have many math functions, trigonometry functions, and statistical functions, string manipulators, and occasionally we got like a XNPV, XIRR, those financial functions, a couple of functions in the financial world. And we'll continuously add more functions from the Excel side based on users' requests. Okay, so what's special about this category of DAX functions? Because they come from Excel, which are cell-based calculation model, so all these formulas are based on individual values. Okay, so the input are individual values, but values, it can be of different data types. It can be a number, can be a date, an individual date, and it can be like a string, right? So or it can be a Boolean value. So all those kind of formulas are based on individual values. And I want to point out that specifically the date time functions, the Excel has its own datetime functions. They are called like a e-date, EO month. So what they do is that they want to shift. So they shift an individual date value. So I take a particular day and I'll produce a new date. Okay, I can shift it by a specific number of days or specific number of months. And also in Excel, I can use the plus and the minus operators directly on individual date values. So DAX can do the same thing. The reason I'm mentioning here is later on I'm going to talk about a different set of functions which are not based on Excel, which are often, like, many users are confused by the two. Okay, so the next set of functions from DAX is inspired from a SQL. So for people come from the SQL background, SQL is the SQL language is based on relational algebra. There's a set of like a table operations. So those table operations, we call them like a selections, also called the filters. Basically, you have a table. If you know SQL, you have a where clause, right? In the where clause, you can specify all kinds of filters to basically to select a subset of rows from this table. So DAX has a similar functions. For example, filter function is for that purpose. Okay, I want to single out the filter function here because later on I'm going to talk about another function that's related to filter context. That's different from the filter function that's from the SQL select statement. Okay, so SQL has like a top end operation. It's another type of filter. And so you can say, I want to select the top 10 rows from this query result. Table, the relational operator has a projection, a renaming, which is I want to, if a table has like 20 columns, I want the result to return only 3 of the columns. So DAX has those functions too, called the select columns. And also the SQL query can say, I want to add some new columns, calculate them on the fly in the result set. DAX has them too, called the add columns functions. So you can add new columns based on some operations based on the existing column values. SQL has aggregation functions and group by and aggregation, and DAX has a ton of those, right? So DAX has lots and lots of aggregation functions, min and max. And for this particular case, there's a little bit of overlap with Excel. So many people are confused by why, for many of the aggregation functions like sum, why does DAX have 2 versions, sum and sum x, count and count x, and count ax, min x, min a. Why do we have so many different varieties? Why don't we just call it count and min? Okay, here we have to tie back to the history of DAX. As I said, one of the original goals of DAX, I believe ever since then we no longer pursue that goal, but that was one of the original design goals, is because DAX was designed for Power Pivot, and we believe eventually DAX will be merged directly into Excel, Excel proper. Therefore, we have to conform to all the existing Excel formula standards, and particularly we cannot break any of the existing Excel formulas. So since the sum, min, max, count a, and they all already exist in Excel, so we must keep them as they are. We cannot change them. Okay, but on the other hand, we have to extend them because we want to work on tables. We are going to extend those formulas to work on tables, to work on columns, to work on arbitrary table expressions. So we keep the sum in the Excel syntax, which only takes a single argument, and then we introduce some new functions like SUMX that can work on any table expression and any scalar expression. But internally, the sum is just a simplified version of SUMX. Similarly, for average, is a simplified version of average X. So there's some misconception out there saying, oh, those are like the reason we have a sum is because it's faster than SUMX. That's not true. Okay, and the reason we have all these different varieties of aggregation function is not because of performance. It's because we have to not break Excel, the existing syntax and existing formula requirements. So we make them a special case of the more generic version of their counterparts. So all the X version is the generic version, while all the the sum, those kind of the original Excel formula names, they are just the specific version. But internally, they all map to the same implementation. Therefore, they have the same performance. You don't have to worry about the performance. Just pick whatever makes sense for you. You don't have to worry about the performance difference between the two categories. Okay, next, and in SQL, there are a lot of join operations. And DAX also has a join functions, but I want to point out that in DAX the
Jeffrey, we can't hear you right now.
and can you hear me now?
Yeah, we can hear you now.
Okay, but I'm going through my microphone on the laptop. That's not high quality. Let me switch back to my headset again, just in case my headset can come back, because without a headset is bad. Okay, can you still hear me?
Yep.
Okay. I just have to switch away and switch back for some reason. Don't know why. Okay, so let me move this aside again. Okay, so so for joins, you really need to create a relationships. Okay, so the reason we have those join functions, and it's because sometimes you have to produce some new tables on the fly, and then the only way to join them, because they're new, obviously they're not the physical data tables in the model, so you cannot create a relationship between them. It's too late. So most of the join functions are there for you to join, for you to correlate the columns between tables on the fly. Okay, you create it in the DAX language. And like a SQL, we have set functions, which means that you can union two row sets. You can find the intersection between two row sets. You can find the difference between two row sets. Like previously in the first measure example, I get a list of customers in the current period and a list of customers before the current period, and then I do a set difference. Right? I use the I find the difference between the two sets, and then I can count the difference as the new customers in the current period. So that's where that's an example of the set function. And we have a bunch of DAX syntax and functions for you to create new tables on the fly. We call them table constructors, and you can fetch column values, so you can jump to another table to fetch some values based on some criteria. And then we have some hierarchical functions. I put them here because they are primarily used to create new columns in a table to support hierarchical relationships in a table, like sometimes called parent-child hierarchies. For example, if you want to represent an organizational hierarchy, many tables only have two columns: the employee ID and the manager ID. So, but in order to generate a report, you want to flatten out so that you can see the hierarchical levels from the CEO all the way down to the individual contributors. So those functions are for those purposes. Okay. So coming back to this, all the functions on this page, all the functions that come from the SQL side, they are more or less related to what we call the row context. Okay. So they are very closely related to the row context, because filter context is for measures. Okay, I'm going to explain to why it's for measures. But in SQL, there's no measures, but there are a lot of row operation, row by row operations, right? So all the functions inside of SQL, they are closely related to the first context of the evaluation context, called a row context, and also because they have a lot of iterations functions on this. So I saw the comment on the internet saying, how come DAX as a programming language doesn't have loops, doesn't have explicit loops? Okay, there are two reasons. One is Excel, we are targeting business analysts. We're not targeting programmers. Okay, so for business analysts, they understand Excel. Excel doesn't have loops, at least it doesn't have explicit loops, right? Excel formulas are all based on individual values. It's a functional language. So DAX is a functional language because of the Excel connection. But on the other hand, DAX has so many SQL functions, even though they are functions, but they internally they are producing iterations over a table and then do something with it. So implicitly, they are all looping functions. There are many, many looping functions here because of that. We call them iteration functions. They are all inspired by SQL. Okay, I lost the focus. Okay, so the last category of DAX functions are inspired by MDX. So what's so special about MDX? Measures, 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 measures. Okay, so all these functions, measures are about the second important context, filter context. Okay, so we have a lot of functions for you to deal with a filter context. Well, here, let me stop here, switch back to my desktop to show you filter context in action. So filter context is primarily for defining measures. So going back to our previous example, right? So we said this measure, new customers, that it just works magically, okay? And because it's the same formula, it will be evaluated on the fly based on the filters in the report. And in this particular case, if I look at this line chart, and now we have this nice little icon is up in the upper right corner. This is like a this icon show you all the filters currently applied to this visual. So I can tell that I have two filters. One is a color is a silver, and the gender is a female. Okay, if I change the filter, I can change it here. Change it to male. I can change the color to blue. Okay, I can add new filters on the fly. For example, I can go to the filter cards. If I scroll it down on the right, I need to first click the visual. I can create a new filter here. As you can see, I've selected the year, quarter, month, day on the axis. So I can say, let me set the filter on year here. And let me switch to basic filter. I can select, let's say, okay, 2000. Oh, I already have a filter. Okay, 2012 and 2013. Okay, I must have already selected the 2013 somewhere else, but it doesn't matter if and oh, it doesn't show me the filters. That's not nice. And does it? There aren't any filters applied to this visual. Okay, so this guy is not showing me these filters, but even though it should it? So let me go back up. Go back up. Yes. So you can see if I go back up. No, this is the wrong one. So if you're on the axis, you will say I have a 2012 and a 2013, right? And but if I change it, if I clear this filter, then I will have a different. It's so hard to see. So let me select it again. Select filter 2013. Let me select 2012. Okay, that doesn't have any new customer. Okay, 2013. Okay, so I can narrow it down to 2013. Now I add a filter year equals 2013. Even though this I need this look like a bug. I need to talk to the engineer who owns this. So the one to show the filter, so I have two filters, even though I have three. One is color is blue, gender is male, and the year is 2013. And for the measure individual values here, I also have the additional filter of July, which is on my axis. Okay, so all those kind of things set up a context. They are the filters. This is the famous filter context. So filter context mostly working on measures. Okay, so the measure, remember, we have that abstract formula that works in a vacuum that somehow magically calculate the new customer count. And then how does it produce concrete results? We apply all those filters that will filter down those customers to a specific product color, specific customer gender, and a specific year and month. And then it will calculate that based on the current filter context to produce a specific value for each data point on this line chart. So different data point on this line chart is applying a different set of filters against the same DAX formula to provide dynamic values across the report. So let's go back, okay, and go back to our slide deck. So now that we know that the filters are primarily designed for measures, so we have a whole set of DAX functions for you to manipulate the filters and detect the filters. We have something called is cross filtered. It means is this table being filtered by anything? Okay, has one value means after you apply all the filters on this column, does it have a single value left? Is filtered means does any filter apply directly on this column? Okay, when I say directly means that if you put a filter, let's say country equals United States, if you say is filtered city, then it will say false because there's no filter directly on the city column, even though it's cross filtered by the country column. So there are all these kind of filter detection functions, and there are also functions for you to manipulate the filters. And the most important function is the calculate function, which I'm going to have a dedicated slide just to talk a little bit more about the calculate functions. That's for you to add new filters, change existing filters, or remove existing filters. And we also have a set of functions that for generating BI queries. So DAX is not only used by the model authors or the report authors to create calculations in their report. It's also used by Power BI UI to generate a BI query on the fly. So we have a set of DAX functions like a summarize columns, a roll up group, roll up by the subtotal, or add missing items. All those functions, if you wonder what they are, their primary purpose is for the UI to generate a query on the fly. The query is also in DAX. Last but not least is called a time intelligence functions. This is as I mentioned in the previous slide, that many people confuse this set of functions with the Excel datetime functions. These functions are used for filter manipulation. So in DAX, when you calculate the year to date, it is a measure. It is, and by measure means it's manipulating the filters. So if your current filter says, let's say it's March 2019, you want to say what is March like a year ago, like the previous years, the same period, right? So what the DAX function does is it say, okay, your current filter is March 2019. I'm going to remove this filter, replace it by a new filter that is all the days in March 2018. So that's how DAX do the calculation of like a previous year, same period the previous year, okay? And so we have a whole slew of DAX functions called the date add, first day, the last day, the first non-blank, like a previous year, start of year, total Y2T, total M2T. All those functions, we call them time intelligence functions. And they work by manipulating filters on the basic measure. And because they're manipulating filters, which are a bunch of columns, like this column equals that value, or the column is equal to a set of values, because they are manipulating filters, so they don't work on individual values. So, and also because they work on filters, they only work on dates that exist in your database. Okay, so you cannot do a same period in the previous year if you only have data. If you only have a dates, not the data, if you only have a dates, let's say in 2019, in 2019, right? So you cannot go to 2018, even though I can easily write a formula saying for a particular date, I minus 365, like minus 365 days, then I should produce a new date value that's 1 year earlier. You can do that in Excel, even though you have no data in the year before, but you cannot use time intelligence functions for that purpose. Okay, so many people say I want to do I want to do a data shift of a particular value, so they call it the date. Unfortunately, all the time intelligence functions are more user-friendly. They have a really nice English names, like a data add. So many people find this function first before they find the corresponding Excel function, which is actually designed for that purpose. I'm going to talk a little bit more about them if I have time toward the end. But just remember, we have the Excel datetime functions, and we have the time intelligence functions. And one is for manipulating individual data values. The other category is for manipulating filters in the filter context. Okay, and so a little bit of history, many people already know, but I'll just repeat this, is what are the usage of DAX, and therefore all those DAX concepts, why we have, like, again, why we have a filter concept, row context, is because DAX can be used in many different places. All right, so let's go back to actual slide deck. We already saw measures. Okay, new customers is a measure. I can drag a column into this report. For example, in this particular report, and I have added 4 measures. I have added customers, which is count of customers, new customers, we already saw that measure, returning customers, another measure, and I also can get a distinct count of customers. So I have 4 measures on this report. So this is what's the make a Power BI the most powerful, adding measures that are dynamic, reacting to the report. I can also add something called calculated columns. What are they? So if I look at the customer table, let me switch to the view. So many people are wondering why we have 3 views. Okay, one is the report view, one is the data view, and one is the diagram view. Okay, the diagram view is for you to connect the tables. Makes sense. Report view for you to create the reports. Makes sense. Why do we have this data view? Okay, what's the purpose of this data view? Data view actually show you the raw data. There is a clear separation before data and the report, and many people don't get it. Okay, and also remember the tables in data is different from the table visual in the report. If I go to a report, I can create a table visual here. And let me just switch this line chart to a table chart. And so this is a table visual. This is not a table, a data table. A data table is what is here. Okay, so in this data table, if I go to the customer table, I can say that originally the customer table has many columns, including first name, last name, and middle name. But what if and the middle name? Okay, what if I want to create what if I want to show report by full name? Okay, and the way I do it is I create a new column. This column called full name. And you can see this is a DAX formula. It says, okay, if the middle name is blank, I just concatenate first name and the last name separated by a space. Otherwise, I concatenate the first name, middle name, and the last name all separated by a slice. So this is a new column, and it's called a calculated column. This is a type of calculated column where each value can be uniquely identified by 3 values on the same row. Okay, imagine I'm iterating over this table row by row. So this formula is getting the values from the other 3 columns in the same row, the middle name, the first name, and the last name, for me to produce a full name. So this is another reason why we have a row context, because the default context in a calculated column is a row context. It makes sense because you are producing a value doing row by row. Okay. And there is another type of calculation, which is a move beyond that. I can produce a new value each row based on the current row alone. For example, I can bucketize all the customers by their income level. Okay, so what I did is I create a new formula, which is a new column, and it first calculate the median yearly income. And I have a yearly income column somewhere on this table. It's a pretty wide table. Okay, I first find the median value, and then I break the customers into high income and low income just by comparing to their yearly income to the median yearly income. Oh, I should have changed the formula. I was demonstrated to another user, so I changed it to using the formula again. I could use the variable directly here. Okay, so I first calculated into a variable, and then I could simply use it right here. And so I compare my current yearly income to the median income. So obviously, in order for me to calculate the median income, I need to scan the table again, right? and so I cannot just calculate this based on my current row. So this is another reason why people are using DAX to create a calculated column instead of some other. You can do that in M, for example, in Power Query, or you can do that directly in the source. But the DAX make it very easy for you to create a calculated column based on some sophisticated calculation, which require you to jump to another table or rescan the current table. Sometimes you have to scan multiple tables. You can be on the product table. You say, okay, I want to calculate the sales for each individual product, and I want to break it down by certain buckets based on the sales. Then you have to jump to the sales table to do that. So you can create a calculated column this way. But all these calculations for calculated columns are happening at the data layer, which means they are completely isolated from the report layer. That's in the first view. While all the measures are in the report layer, that means the measure formulas are not evaluated until you have set all the filters and then you have created a report. The calculated columns are calculated directly inside the data layer. Therefore, nothing you do in the report layer will change its results. They are completely separated, isolated. There's a big stone wall between these two layers. Calculated column become a physical data, just like the physical columns that you directly imported from the source. They cannot change. It becomes materialized along with the underlying table. And that's also why it's so fast. You can have a very complex formulas. It takes a while to calculate, but once you calculate, they are saved, persisted. So when into the report, I can create a report directly using a calculated column. For example, here I add a report based on full name. That is calculated column, and then I want to calculate the water quantity, and based on the full name, and also based on the income bracket, and then they will produce a report on the fly. They are subject to all the filters. I can set them as a filters. Okay, so this is a calculated columns. They have a row context, while the measures are the initial context for measures are filters. We already showed. So the third usage of DAX is used to define row level security. So by row level security it's a security feature. What you do is if you go to here, let's say, and I can define three security rows. One is called the Europe row, one is called the North America row. So what it does is it simply has a DAX formula saying this column, there's a group column. I say group equals Europe. And for the North America row, I said group equals North America. So this is another, like the initial context is a row context. So this formula is evaluated row by row. Unfortunately, we don't have a nice UI for it. So you are kind of like have to know the data structure of the table and the columns, those kind of things, and what values in there before you can write a meaningful expression here. But essentially, it's very much like the calculated column formula. The initial context is a row context. So once you author this formula, you can the way you use it is if you look at the actual report. For example, I have a report. It's a map showing sales, global sales all over the world. But imagine you have this report and let's say you have a restriction, say North American users can only see North America sales, European users can only see Europe sales. Then you can invoke row level security, which is a row by row calculation. And what you do is you can, if I invoke those calculations, let's say if I say Europe, when I say Europe, you will say that now my sales, my sales is narrowed down to, I will only show you Europe sales. I can switch the view back to I can cancel the row level security simulation mode. Then you'll go back to see all the sales across the globe. Okay, so row level security is another application of measure of DAX, and its initial context is row context. All right. Last but not least, DAX, you can create tables called calculated tables. So once again, calculated tables belong to the data layer. It's just like any other physical tables. It's materialized, therefore it's not subject to filters in the visual layer, in the report layer. There's no report you can set that can affect the outcomes of the calculated tables. That's very different from the tables in the actual report. That's a different thing. It's a different table. Right? So for example, here I have a sales table, and if you look at my data layer, and look at my sales table. It has many columns. It's at the granularity of individual dates, of individual products, and individual customers. And I create another calculate table saying, based on the same sales table, I'm saying, instead of showing me at such low granularity, I want to see sales by year. I want to only say the year granularity and married, unmarried customers, and at the product category. So you can see now I have a much smaller table, even though it's based on the same sales table over there, at higher granularity at the year, product category, and the marital status thing. So some people use this technique to produce high performance queries, because now you are querying a much smaller table. So this is also using DAX. And as you can see, imagine this is very much related to the SQL functions of DAX, right? The SQL is producing a new query result, and then in this case, we materialize it. So because DAX has so many different usage, that's why we need a different context. So this is another explanation why we need a filter, the distinction between filter context and row context, because DAX is so versatile. It's used in so many different ways in so many different places. So we have to have a specific designs to cater to the specific situations for its usage. Yeah, and once we created those calculated tables, for example, I can create a new table from scratch based on like data doesn't exist in the model at all. For example, for demonstration purpose, I create a beta distribution. You can see that no, not this one. The next one, I can show a beta distribution curve, even though this data does not exist at all in the original table. I can just create the tables on the fly, create a new data on the fly for all kinds of purposes. All right. So this is for the calculate tables. So it's already 10 o'clock. I'm sorry we have to start late. And so do we want to continue or we want to stop here? Hello?
Yeah. Hey, Jeff. How much longer do you think you have left?
Well, there's no way we can finish everything. I can just quickly go over one more thing about the row context, filter context, and then we can stop there. How about that? Okay, because we're already very deep into row context, filter context. Maybe we just want to do one or two slides.
Yeah, we can also talk about maybe covering the second half in another presentation.
Sure. Okay. And so row context, filter context, we have seen lots of examples. And the row context, we said for calculated columns, row level securities, their initial context is row context. For Power BI visuals, and for people who are familiar that you can actually connect Excel directly to Power BI, and the Excel using pivot tables, and the pivot tables, the initial context is filter context. Okay, and once you have the initial context, you can manipulate them. Okay, so for the row context, it's those iteration functions. Like iteration function, you can like looping functions. You have a table expression, you go row by row, and then each row is adding to the row context, and then you can do some calculations. For filter context, it's the famous calculate function. There's some people say calculate table, and the calculate function is for you to manipulate filter context. This is my last slide for today. So I just want to talk about that calculate. Many people use it primarily to add new filters, to remove existing filters, or change existing filters. But it does another very important thing. Calculate function convert rows from row context as a filters into the filter context. That's why you can drag a measure into a calculated column. When you drag a measure into it, since a measure works with filters, right? It doesn't work with rows. So even in a row context, let's say I'm in the product table, I have defined a measure that's simply sum of sales amount. If I add that measure into your calculated, if my calculated column expression simply equals sales, like a total sales, which is the name of the measure, you will see, well, magically it will just tell you the sales for the current product rows. Is it observing the row context? No. What it does is because the measures is like a calculate function, it converts the current row as filters. So basically, the current product becomes a bunch of filters, like a product key equals this, product name equals that, and then we use those set of filters to filter the sales table, and then I produce a sum based on that. So calculate function does this magic thing that converting rows into filters. And another caveat of DAX is all the measures are implicit with a calculate. Right? So all the measures, you define expression. You don't say calculate. You say sum sales amount. What it does internally by DAX engine is wrap that formula in a calculate. So it's a calculate whatever the measure expression users actually typed. So if you simply typed sum sales amount, so the real formula is calculate sum sales amount. Because the implicit calculate implied by all measure names, it does this magical row to filter conversion. This is why you can define a calculated column as a measure name, and somehow it performs a filtering function because it's implicit conversion from row to filter by the calculate function. And as I already mentioned, filter function belong to the SQL category. Therefore, it's an iteration function. It's different from the calculate function, which is for manipulating filters. Filter function is actually for you to add rows to a row context. Even though it's called a filter, don't confuse it with a filter context. So this is enough for the caveats related to filter context, row context. You have some background. So to recap, today we'll talk about the different inspirations of DAX. Now you understand that the different DAX belong to different categories, and also they have different usage, and all those are the reasons we have a mixture of Excel, SQL, and MDX functionalities, and also because DAX are used in different situations, and that's why you are seeing this, like why do we have this like the distinction between row and the filters in DAX. And the last but not least, one of the reasons DAX is hard is not because DAX is hard. It's because DAX actually is mature. Remember, DAX is based on 20 years of history. And also, when DAX was first created, Power BI UI does not exist at all. We have a Power Pivot. So when Power BI team gets started, they have to start from scratch. As a result, the UI took several years to catch up. And before they catch up, a lot of UI operations, users have to do it using DAX. For example, some formatting change from a number to show a specific string representation of a number. All those kind of things really should not be done in DAX. DAX is for you to manipulate the data, do analytics, to calculate. It's not for you to do formatting. That's really UI's job. But before UI became mature over the years, many people have to resort to DAX to do those kind of like a formatting and a representation layer functionalities. So people say DAX is hard. It's really not because the DAX itself is hard, but rather, why do I need to do programming at all? Why do I need to use DAX to do this kind of simple things where all the mature reporting products can do easily? So that's the don't be confused by the fact that the DAX is not hard, but the DAX is actually helpful. It's being borrowed to do something until the corresponding UI functionalities has been added to the products over the time. So that's why the product is getting easier and easier to use, because people are doing less and less those unnecessary DAX formulas. So that's what we have today. And if you have any questions, you can always email me afterwards. I'm happy to answer any questions afterwards. So yeah, sorry again that we start late because of technical difficulties. Next time, if we do this again, I'll remember to use this machine instead of my other machine.
Jeffrey, thank you so much. We had a really good turnout, and I think everyone would love it if we could schedule a second part to this
Sure.
Learn DAX presentation. We can talk about that offline.
Yeah, we'll talk about offline. Sure.
Yeah, I'm sure everyone would be happy with that. Just everyone that attended, we will have the presentation recorded and uploaded to our YouTube page. And I see a lot of questions coming in saying that they want to have the next second part of this. So we'll definitely definitely talk with Jeffrey after the meeting and get the second part scheduled.
Sure.
So we continue, and I guess I'll just keep an eye on it. We're on DAX 11, so to start off right where we left off.
Yeah, I want to thank you for organizing this event and for inviting me over. It's my pleasure to
Yeah.
talk
No,
to.
thank you for presenting. It was like I said, a great turnout. Everyone in the comments are very happy with the presentation. And can you provide? I guess after we do a lot of people are asking about the slides. Maybe we can get this second part scheduled, and then I'll get you to send out the slides as a whole.
Okay, sure. Yeah.
Because I'm sure if we just send out the whole slides, and people may get confused with jumping ahead.
Uh-huh.
So thank you everyone for attending. Jeffrey, thank you for presenting, and let's get the second part scheduled so everyone can get involved.
Okay.
All right, everyone have a good day.
Okay, thanks. Have a good day.
All right, bye.